Okay, I'm going to start with going over number 12 from your homework from last week, since we never went over it because someone was crabby during class, and so we never got there. So I'll give you that function, and it says, at the indicated point, find the slope of the curve and the equation of the tangent. And that's all I wanted you to do so far is just A and B. So at x equals 0. So the slope of the curve and the equation of the tangent. So remember, the whole idea on this is some kind of parabola. And at x equals 0 some point, I don't know where that is, let's say it's right here, who cares, it doesn't matter. But if we're going to find the slope at that point, the whole idea is we're going to have some random point, like let's say here's x equals 0. We're going to have some random point out here, we usually call it h, right? Just some point to the right of it. And we're just going to take that point and, using the limit, move it as close as possible to that one. So we take the limit as h approaches 0, right? Because this is 0, this would be, I guess this would be 0 plus h, which is just h. But so as that point gets really, really close to that point, that'll become the slope at that point, right? Because the slope at that point would be much steeper. So that's like the whole idea. So we use the slope between those 2 points. So if we do that here, we got to figure out what our 2 points are. We're going to have 0, comma, something, right? This point right here is 0, and I just use the function, plug it in. If I plug it in, 0 minus 0 minus 1, 0, negative 1. And the other point I'm going to use would be 0 plus h, like I said over here. Right, just some point to the right of that. Well, first, on this one it's easy. You don't have to put 0 plus h because 0 plus h is just h. So some point to the right of that. And if I plug in h to here, I get h squared minus 3h minus 1. So I'm finding the slope between those 2 points. So if I do my slope, change of y over the change in x, right, I subtract my y values, so I'll have h squared minus 3h minus 1. There's that, minus negative 1 over h minus 0. You gotta remember to pause sometimes on these. I just spilled water on my paper. Dang it. My only piece of paper too, so hopefully I don't run out of room. Now you just got to simplify this, which sometimes is easy and sometimes is difficult. This one looks pretty easy. Minus a negative 1, that's just plus 1, so I have h squared minus 3h minus 1 plus 1 over h. Negative 1 plus 1 is 0, so I got h squared minus 3h over h. Whoops, which factor out an h on the top, cancel an h, and you get h minus 3. Alright? So, that's cool, whatever. That's the slope between those 2 points, right? That's what that is. So if I drew a line between those 2 points, that's the slope. It's h minus 3. So if h is big, if this point's way over here, my slope will be bigger, right? Makes sense. If I move this point way over here, my slope is bigger. Then if I move the point closer down here, my slope is smaller. If I move the point a little closer, my slope gets smaller, right? So the whole idea is I'm taking the limit as h approaches 0, because I want h to be really, really close to my original point of h minus 3, and that is equal to, in this case, just plug it in, right? That's how you do limits on these. 0 minus 3, negative 3. So there's my slope at that point. So obviously my drawing is wrong. This is not what it would look like because I got a negative slope. So I was just using that drawing for the idea. If you wanted a perfect one, well, I don't feel like doing it because I would do it right here, and that spot on my paper is wet, so I can't. Sorry. So there's your slope. So then it also asked, find the equation of the line, of the tangent line. Well, that's just the equation of that line. You know the slope, you know what point it goes through. So the easiest way to do it is in point-slope form. Remember, y minus y, slope, x minus x. So just y minus, this is what it actually is. I'm going to write this every single time until you guys remember it, because it's so easy. So all I have to do then is y. Actually, this one's easy too, because there is, if you wanted to do y equals mx plus b, because if x is 0, that is your y-intercept. So I guess y equals mx plus b would be easy. Negative 3x minus 1. Right? Or this form would be y minus negative 1, so y plus 1 equals the slope times x minus the other point. There it is in point-slope form, which obviously x minus 0 is just x. So you can see really easily how you get to the other form. Either one. Doesn't matter. You can write your answer either form. This saves you time though. So that's it. That's how you find the tangent line. So some of these, we're going to do more of these right now. This whole idea of finding the slope at a point. And you've done part of this before. There is a formula, I guess, for finding the slope of a curve at a point. And we just used it without really knowing it. So slope is m equals, and all we did the limit as h approaches 0. Right? And we did it of this thing. Well, this was the simplified version of this. And what this was, this, we took some value x. For x, we took 0. And we just added h to it. So that's pretty much x plus h. But when we write this formula, we don't really put an x in there. I don't know why. We say, at our point, x equals a. So if we want to, here's a. If we want to know the slope of a curve at that point, we say x equals a. And so our other point, then, like right here, that would be whatever a is plus some value of h above it. So really the formula, all it is rise over run. So if you think about change in y, if I subtract these y values, well, you might be like, well, I don't know the y values. I know the x value is a, this x value is a plus h. Well, to get the y values, you just plug it into the function, right? So what you do is you do f of a plus h minus f of a. Right? That's just changing y. Remember, that means what is the y value when x equals a plus h? That is, what is the y value when x equals a? Right? And then on the bottom, you're going to have a plus h minus a, which I'll just simplify that. A plus h minus a, right? That'd be my change in x, which a minus a is 0, so really it's just h on the bottom. So there's your formula for the slope of a curve at a point. It's really just rise over run with the h in there. So hopefully that makes sense. And you did this right here. There's f of a plus h right there. In this case, a was 0, so it was really just f of h. And we plugged in h for that, and we got that. Right? That's that part. Then we plugged in a for our thing, which ours was just 0. So we plugged that in, and we got negative 1. So there's that part. And then on bottom, we just had, hey, we just had h. And then we simplified all that crap, and we did the limit as h approaches 0. So this is all we've been doing right here. And you've actually seen part of this before, which I need both hands. But if you just look at that, that might look familiar. F of a plus h minus f of a over h. We did a whole bunch of those last year, where I'd give you a function and I'd give you that thing and make you plug in a plus h and a and simplify it. It was called the difference quotient. We did a whole bunch of those simplifying, and I told you we would use it this year, and well, here it is. So we're going to use it now and do another example. This one will be a little harder though. But it's not harder, it's just more algebra. It's just harder to simplify. I might have to go get a new piece of paper. So if we have f of x equals 1 over x, we're going to find the slope. At x equals a. So in this case we're going to do it with letters. And all the ones we've done before, we used numbers, we did rise over run, and it was easy. Now we're just going to use x equals a. So this looks something like this. This is just saying at any point a. So it could be at any point along over here or along over here. We don't know. Who cares? We'll call this a. And then we're going to go somewhere to the right of that. And that's going to be a plus h. And so we're going to use that to calculate our slope. If it helps you to write change in y over change in x, you can do that. Or you can just know you're going to go the limit as h approaches 0. And on top, change in y. Well, the y values, we don't know them. But if I plug in a and I plug in a plus h, I can calculate my y values, right? So what I'm doing, I'm going to go f of a plus h minus f of a. Those are my y values. Then on bottom, just so it's not so confusing, the x values are a plus h minus a. So we got a lot of simplifying to do here. So right, change in y, change in x. On bottom, a plus h minus a, that's easy, it's just h. On top, I got to plug those in to get my y values. So I'm going to have 1 over a plus h minus, I got to plug that in, so that's 1 over a. And I think I gave you this one last year. You just had that, and you had to simplify it. The only new part is now at the end you have to do the limit as h approaches 0. So this is good review here. To simplify that, right, ignore the bottom, do the top, get a common denominator. Probably would be cool if you like pause the video, maybe try it. Don't take more than 3 minutes though. So I'm going to give you the answer right now. So on top, in order to subtract those, we need a common denominator, and it's not just a plus h. Remember, you have to multiply the two. So our common denominator would be a times a plus h. And on top, this one already had the a plus h, right? So I have to multiply this by a on top and bottom, right? To give it, this is just fraction stuff. I know that's our strong point here, so this should be easy, right? So our common denominator is a times a plus h, so I multiply this on top and bottom by a, so this is a, right? A times 1 is a. On bottom I have a times a plus h. Minus, this one needs a plus h, so I multiply the top and the bottom by a plus h. So bottom I have a times a plus h. On top I have a plus h. Put it in parentheses though, or you'll mess up. So I have that. And this whole thing is over h. We'll worry about that guy later though. Right now we're just taking care of this top piece. So now I have this, simplify it. We'll have a minus h, right? Distribute the negative. So a minus a is 0, and then minus h. So on top I have negative h, and then I have a times a plus h all over h. So you can think of that as like your top. So you have that divided by h. So I'm dividing fractions, I flip and multiply. So now I have negative h over a times a plus h times 1 over h. Right, took the bottom, flipped it, now multiplying. Well, this is multiplying. So when you have the same thing on top as on bottom, divide into 1. So now I have negative 1 over a times a plus h. That's it. I can't go any further than that. I've simplified it as completely as I can. So now I need to do the limit as h approaches 0 of that. Well, that's easy. Just plug in 0 for h. So I have negative 1 over a times a plus 0. A plus 0 is just a times a. It's negative 1 over a squared. That would be the slope when x equals a. So if you went back and you changed that to 5, and you plugged in 5 and 5 plus h, and you did all this work, down here you would have negative 1 over 25, because it's just whatever you pick for a is squared, and it's negative 1 over that. That's your slope at that point. So you can pick any point along there and do this whole process, and you'll get negative 1 over whatever point you picked squared. That's the slope at that point. So I could ask you, could give you that, and say, when will the slope of that be? And I could pick any number. So I could say, when will the slope be? Let's go, we'll make it easy. Negative 1/9. So if I said, here's a function, f of x equals 1 over x, when will the slope be negative 1/9? So all you have to do is do this, use some arbitrary value, use a, do the whole thing. So I get negative 1 over a squared. That's my slope. So when will that be negative 1/9? So you say, oh, here's my slope, negative 1 over a squared. When will that be negative 1/9? That's pretty easy. You can probably just do it in your head. Oh, negative 1 on top. So when a, or when x, a and x are the same thing, when it's 3, or negative 3. Interesting. Could be negative 3 also. 2 different points. Yeah, because negative 3 squared is still 9. That works. So when x equals 3, I have a slope of negative 1/9, and when x equals negative 3, I have a slope of negative 1/9. And if you look on your graph, when x is like 3, that'd be somewhere over here. Right, here's one over here, that looks like about negative 1/9. And if you come over here, you'd be up here somewhere at negative 3. Slope is also negative 1/9. Makes sense. So that's just finding the slope again. Just doing this, changing y over changing x, and simplifying. That's all we've done the last few times. Now we're going to talk about norm. We could do the tangent to that curve, right? We just use our slope and plug in the point it goes through. Can't do it on this with just a, but like if I said, what would the equation of the tangent line be through that point? You know your slope, you know a point, so you could, right? So let's just, might as well just do it. So find the equation of the tangent line. At x equals 3. Gotta give the other point. Well, we know the slope's negative 1/9. We know our point is 3. Well, just use the equation, right? If you have x and you want to know y, so it's 1 over x. So there's my point. So then that means my tangent line, the equation would just be y minus 1/3 equals negative 1/9 x minus 3. And there's where point slope form will save you a lot of time, because you don't have to mess with stupid y equals mx plus b and all those fractions. You just write it like that. So that's our tangent line. Now we're going to talk about the normal line. But I think I'm out of paper, so I'll be right back. I'll be really fast though. Told you I'd be fast. Okay, all the normal line is it's the line perpendicular to the tangent line. So, using our parabola example, if we found the tangent line at this point, that's the line that just touches it barely right at that point, right? The normal line, which I don't know where they came up with the name, normal to a curve is the line perpendicular to that one through that point. Let's see that. So to find the normal, the line normal to a curve. I don't always write out all the words. But to find that line, all you do is you find the slope of the tangent line. And then they're perpendicular, right? So you just use the slope to find the slope of your normal. And then you use that point to plug it in. So let's go back to number 12. This was from the homework. Let's see. So if I said find the equation of the line normal to the curve at x equals 0, what you would do is you find the slope of the tangent line first using this whole idea. And so we do all that, blah, blah, blah. Hey, our slope was -3, right? So that was our tangent line. And let's see, our function was, can't remember, x squared minus 3x minus 1. And we were doing this at the point x equals 0. So we had that parabola, and at that point, our tangent line slope was -3. We already did all that work. So finding the slope of the finding the slope of the normal is easy, right? If it's perpendicular to that, remember perpendicular lines. So our slope of our perpendicular, right? It's the negative reciprocal, or flip it and change the sign. So instead of -3, it's going to be positive. Flip it, 1/3. Boom. Got my slope of my normal. So to get the equation, again, I just use point-slope form. Remember, when x is 0, plug it in, y was -1. That's the point I was going through, was 0, -1. And this parabola would be something like that. Right? My slope of my tangent line was -3, so something like that. The slope of my normal is just 1/3. And I'm going through that same point, so all I have to do is y minus -1 equals 1/3 x minus 0. Right? Just plug it. That's a good answer. Well, you can make y plus 1. So you just use the same point, and you just have a different slope. It's really not much new. So there's a good answer. Or if you wanted it in y equals mx plus b, you could have 1/3 x and then -1. That would work. So that's all the normal to a curve is. So you're going to have to do that on like on 12. Find the slope of the curve. That's doing the whole change in y over change in x. Equation of the tangent is then you use that slope and plug in a point. So you just put it in point-slope form. That'd be the easiest. Equation of the normal. Well, take your slope that you found, flip it, change the sign. There's your new slope. And then use the same point to get your equation of the normal, and then draw a graph of all of it. You can use your graphing calculator, but you're going to have to do number 10 and 11. Same thing. So the same whole process. Do the change in y over change in x. Use this. Do the limit as h approaches 0. Okay. So that'll be those. Let's see what else. You're also going to have to do 17. This one's kind of weird. It says determine whether the curve has a tangent at the indicated point. If it does, give its slope. So I'm going to have you do 17, no calculator. says find the slope at x equals 2. So it's just like these before, but you have to just decide which one to use when x is 2, and then go from there to do your whole process. And then, let's see, 25, 27, you're going to do a bunch of that. You're going to do a couple of story problems. All it is, remember how we talked about speed, and we talked about average speed versus speed at an exact time? Well, the slope as a point, if you're talking about speed, and you have a graph, or you don't even have to have a graph, you have a function, if you have a position function, so this is like this first one, f of t equals 3t minus 7. This is just t is time, f is probably, feet. So whether something's falling or moving, who cares, whatever. Like on this one, if t was 10, this thing would have moved 23 feet, because I plug in 10, I get 23, right? So if it's saying find the instantaneous rate of change, all that's saying is find the speed, or find the slope at that point, right? Rate of change means slope, which if you're talking feet versus time, the slope, maybe I'm going too fast here, but if something moves this many feet, and this is time, doesn't matter what it looks like, who cares? All right, if I say find the slope at this point, the meaning of the slope, right, rise over run, I do this number divided by this number. The units would be feet divided by whatever, seconds maybe. So the units feet per second, the units of the slope is speed. So when it's saying find the instantaneous rate of change, that's just the slope at a point, which is just a speed at a given time. So these things all mean, it's just different ways of saying the same thing. All you're doing is finding the slope at that point. And it's just using f of t instead of y equals, and it's just using t instead of x. So this is actually the exact same thing as this, just with some different wording. Don't let it confuse you. You're doing the same thing. You're finding the slope at a point. That's the instantaneous rate of change. 27 and 28, I know you all love story problems. Here's your function. They tell you its height above the ground after t set 100 minus 4.9 t squared. There's your function. There's f of t. How fast is it falling? 2 seconds. So t equals 2. There's your point that you're finding the slope at. So it's the exact same thing as this, which is the exact same thing as this. It's just worded differently. So there's your function, there's your t equals or your x equals, and you're doing the exact same thing. So in this homework assignment, you're doing this whole process a whole bunch of times. Just worded differently and presented differently. So don't get confused. Don't say, oh, I don't know, I didn't know how to do number 27. Well, yeah, you do, because it's the exact same. If you can do 10, you can do 27. And if you can do 27, you can do 25. They're all the same thing. I can't emphasize that enough. Every problem I give you on this homework problem, you are doing the same thing. So, here we go. It's going to almost do one more example that I feel like this video is dragging on. I want you to do 10, 11, 17, 24. If you want one more example, let it play. I'm going to do one more real quick, or you can watch it at home, whatever. If you tired of listening to me talk, just shut it off, because I'm just going to do one more example of how to do this whole process. I forgot how long the first video was. I know this is getting long now. So I'll pick one of these just so it looks a little different, just so it's not like, let's go with the hardest one. I don't know, maybe 26. So f of t equals t to the third minus 1, and t equals 2. Another way I could word this is say, an object is dropped, blah, 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 Its height above the ground was t to the third minus 1 after t seconds. How fast is it falling after 2 seconds? Well, if you're like, I don't know how to start, you can either memorize that formula, or you can just think change in y over change in x and get your point. So my first point, 2 comma what? And then my other point, what's it going to be? Draw a picture if you need to. T to the third power, that's going to look something like that, who knows. So at 2, I don't know what it looks like. So I'm going to have 2 something, and then I'm going to have some point to the right of it. And what are we going to call that point to the right of it? That's 2 plus h. That's the x value. It's 2 plus h. So that's a good place to start. And then plug these in. Plug in 2. 8 minus 1 is 7. Plug in 2 plus h. I don't know. 2 plus h to the third minus 1. Right? So if you do use the formula, where'd it go? You've already done f of a plus h. It's right there. You took a plus h and you plugged it in. You've already done f of a. It's right there. You took a and you plugged it in. And then here's your a and your a plus h. Because when you do your slope, so we're going to do the limit as h approaches 0, change in y will go on top. So I'm going to have a change in y. 2 plus h to the third minus 1 minus 7 over change in y, there's I subtracted those, change in x, 2 plus h minus 2. Right? That's all this is. I plugged in a plus h. In this case a was 2. So I plugged in 2 plus h for this. There it is. Well, there it is. I plugged in 2. There it is. And then on bottom, I did a plus h minus a. So now I just got to do a whole bunch of simplifying here. Bottom's easy. Tube, it's always just h. 2 plus h minus 2 is h. Top, oh crap. I got to go 2 plus h to the third. Do not put 8 plus h to the third. That's horrible. It's 2 plus h times 2 plus h times 2 plus h. Well, that sucks. But here you go. You just got to be fast. 4 plus 2h plus 2h plus h squared. Then I take that times 2 plus h. So I got 8 plus 4h, right? Just distributive property. 8 plus 4h plus 8h plus 4h squared. Then h squared times that would be plus 2h squared plus h to the third. Combine like terms. So let's see, I got an h to the third. 2h squared plus 4h squared is 6h squared. 8h plus 4h is 12h. And plus 8. Oh, I was like, something happened. Something's wrong. Because I forgot something. I just did that. 2 plus h to the third. There's that. But I still have minus 1 minus 7. So minus 8. That should always happen. I mean, the reason I knew something was wrong is because I had that plus 8 there. And I couldn't divide out the h. You'll always be able to divide out an h at the end when you do this. Plus 8 minus 8 is 0. So there we go. I got h to the third plus 6h squared plus 12h over h. Divide out the h. So I got h squared plus 6h plus 12. There we go. Limit as h approaches 0 of that. Alright, so really all I've done, I plugged that in and I just simplified that thing. All it is, I took that, simplified it, there it is. Now I'll do the limit as h approaches 0 and I get 12. So that is your slope of the tangent line. Or in this case, that is your speed when t equals 2. Or that's your instantaneous rate of change when t equals 2, however you want to word it. So on this one, if I was just doing this problem, find the instantaneous rate of change in feet at the given time t, I'm done. It's right there. That's my instantaneous rate of change. And in this case, t was in seconds and it was in feet, so that would be feet per second. If I was doing one of these, I would have a done. That's the slope of the curve at that point. If I'm finding the equation of my tangent line, I've got my slope, 12. I've got a point it goes through right there. I did that earlier. It's 2, 7. So my slope, or my tangent line equation would just be y minus 7 equals 12 times x minus 2. There's my tangent line. If I wanted the equation of the line normal to the curve at that point, all I would have to do, my slope, got to flip it, change the sign, so I'd have negative 1/12. There's my slope of my normal. So if I know the slope, it still goes through that same point. It still goes through that point right there. It's just, instead of tangent to it, now it's normal to it. So got my new slope. Hey, use that same point. Y minus 7 equals that. Boom, there's your normal. That's all this is. Same thing everywhere. Okay, have fun.